Okay. So again, our goal here today is to solve systems using equal values method. If you guys could switch to the page that says lesson 3, solving systems by equal values method. I want to start off with a little bit of review and warm up. Right at the top, you see two equations that are both in slope-intercept form. Let's get that phone put away, please. Could you please graph these two equations on this grid right here and find me where they intersect? So this is just like we did in the homework. Are you on the right page here? Page 4, the one that says lesson 3 at the top. Yep, okay. So graph me these two equations. I'm going to work through two. If you need a little review on how to graph the equations, follow along with me. If you can do it on your own, feel free to ignore me and do it on your own. Just pause when you finish. So I'm going to put a 1 in front of my x here. It's actually 1 over 1. That's going to have a negative slope. So it's going to go downhill. It's going to go down 1 over 1. And has a y-intercept at 3. So I'll start here at 3. And then count down 1 over 1 to get my negative slope. Back it up. Got them both graphed? All right, my second equation has a 2 in front of the x. It's actually a 2 over 1. And it's positive, so this one's going to be going uphill. So I'm going to go up 2 and over 1. We need to be very careful with positive and negative slopes. That's where a lot of folks are making mistakes. It's a really easy mistake to make too. So double check always. 2 over 1. So I need to start at negative 3. And count up 2 spaces over 1 space. Right up there. If you have homework, there's a tray to turn it in. Did you pick up a late slip on your way in? Okay. Thank you for the reminder. All right, our intersection point here is what we're going for. That's going to give us our final answer. We'll write that as a point in parentheses. Remember, x comes first and then y. The x value of this point is, let's see, 2. And the y value is 1. So 2, 1 is going to be our final answer. That's our solution to this system. How'd you guys do with that? We feeling pretty good about graphing? Let's get the phone away, please. Put it in your bag. Just leave it on your lap. It's a bad choice. Just a quick reminder, folks, I have given everybody a warning about the phones, and I've given a couple people some individual warnings. You get one individual warning, and then you get the paper bag thing, okay? Which comes with a free write-up and phone call home. All right. So do the smart thing. Put it in airplane mode, stick it in your bag, because you're not going to want to have it out. Okay. Here we go. So that's how we do it with a graph. I want to show you how we can solve this equation without a graph. So algebraically, how we can solve this system of equations. So could I get you guys to, over here where you've got a little space, could you rewrite your two equations, y equals negative x plus 3 and y equals 2x minus 3. So I'm just rewriting the same thing that we had over here. So here is how equal values method works. When you have an equation where you have y equals, actually could say x equals and x equals, as long as it matches either y equals and y equals or x equals and x equals, you are allowed to take the two other parts of your equation, the things that y are both equal to, that's why it's called equal values method, and you can stick them together into one single equation. So this equation would look like this. It would say negative x plus 3 equals 2x minus 3. So I've taken my two equations and combined them together into one single equation. That's the key step to equal values method. Take your two equations, combine them together into one. Now we have an equation that only has x's in it, and we can solve that. Let's do a little annotation here off to the side. Step 1 here, I would say we combined. Sorry, you can't see that. No, it's on there. We combine the two equations. Step 2 is going to be to solve. Now this is going to take a couple steps of algebra, but you guys have solved lots of equations like this. You might think about putting a 1 in front of that x there. So when I look at these two equations, I see that I have x's on both sides. We can't solve an equation that has x's in two places. So I need to get rid of the negative 1x or the 2x. Which one should I get rid of? The negative 1x or the 2x? You want to get rid of the 2x, but you want to get rid of the negative 1x. Huh, we're in a quandary. Both of you are correct. There's no wrong answer here. So I'll tell you what, why don't you get rid of the negative 1x? We'll get rid of the 2x because that's the one I heard first. We'll see if we end up getting the same answer. Okay, we should. So you chose the 2x. I'm going to go minus 2x because that was a positive 2x, and minus 2x over here. Those are gone now. Negative 1x minus 2x. Be careful with my signs here. That's going to be negative 3x plus 3 equals negative 3. You like to avoid the negatives, right? I'm with you, because negatives are where we tend to make mistakes. So, all right, let's see if we match though. Okay, now I'm looking at this x here, trying to get it alone. Let's get rid of this plus 3 first. Let's save. We're going to have to divide this, but I always like to save dividing for the end. I think we talked about that last week, right? We can divide whenever we want to, but I'd rather divide at the end because sometimes that causes fractions. So let's get rid of this 3 with subtraction. This plus 3 will go minus 3 on both sides. That'll get us just negative 3x equals negative 6. And now in our final step, we'll go ahead and divide everything by negative 3 because that's what's multiplying the x. And I'll get x equals negative divided by a negative is positive, and 6 divided by 3 is 2. Is that what you got also when you did it the other way around? All right, excellent. So we went two different paths, but we got to the same place. So step 2 is kind of the big step. It took us a little while to solve it. Now we're halfway done in terms of answers, but we're like 90% of the way there in terms of the work, okay? Because remember what I said, when we're solving these, we need to find an x value and a y value. We found our x value, it's 2. We also need to find a y value. Anybody know how we're gonna find the y value? So this is gonna be step 3. So we need to go back to one of our original equations, and it does not matter which one you choose. All right, so which one do you want to choose, the first one or the second one? The second one? because it's got a positive in front of the x? I think that's a good idea. So I'm going to copy this down here. I'm going to draw a little arrow and write y equals 2 blank parentheses minus 3. Do you see what I did there? I left out the x and I put a blank parentheses in its place. Why do you suppose I did that? What do you think? Because we got a number for x, right? It's 2. We figured out that x was 2. So we can take this 2 now and pop it back in there in place of the x. We're substituting that 2 in. And then this, we can now work out what y is. Y equals, what's 2 times 2? That's 4. And then we got 4 minus 3, which is -1, +1, 1. Yeah. So we got x equals 2, y equals 1. We've come up with both of our answers, and we are done. All right, what do you guys think? So usually this is the lesson where my Algebra 1 students say, wow, that's a lot of work for one problem. Do you agree? It is quite a bit of work for one problem. You're going to do some of these in your homework tonight. You know how many I'm going to ask you to do? 10, 20, no, 4. You're just going to do 4 of them. Because it is a lot of work for one problem. But you're going to get good at this. You're going to get quick with it. This is the first one we just talked it out. It took us about 7 or 8 minutes to do it. We're going to get much faster. I want you to notice something. When we graphed it, what was our intersection point? 2, 1. Do you think it's coincidence that we came up with those same exact numbers when we solved it algebraically? That's definitely not coincidence. We actually solved this problem 2 different ways. Now, some of you are going to say, why would I ever do it this way when I can just graph it? And that's a good question. The answer is sometimes the equations are going to have really big numbers in them and you won't be able to graph them. So we're going to run into equations where it's like y equals 1.6x minus 5,000. And you don't want to make a graph and have to count down 5,000 to find a y-intercept. So that's why we want to have an algebraic method. Okay, so we're just going to practice this for a couple examples together. We'll just go through those same steps that we did just a moment ago. So the first step is the key step, and that's where we combine the 2 pieces of the equation together. So I'm going to take these 2 equations, combine them into a single equation, negative 7x plus 4. Basically, we just pop an equal sign in between them. Negative x minus 2. And I like to have 1s in front of, I like to have every variable with the coefficient. So I want to stick a 1 in there. All right, and then we need to solve that. So go ahead and do your steps. You got x's on both sides. So which one are we going to get rid of this time? The negative 1x or the negative 7x? If I'm trying to have less negatives, I think I want to get rid of the negative 7x. That's what I'm going to go with this time. It's negative, so I'll do plus 7x on both sides. Now that we have x in just one place, we can work to get that x by itself. So I'll save the division for last because I don't want to deal with fractions just yet. Let's do plus 2 on both sides. Get rid of that minus 2. And now we can divide to get rid of that 6. That gives us half of our answer. Hooray! By the way, if you are struggling at all with solving these equations with this step right here, please let me know. I can get you caught up on that really quickly. We'll sit down with you while we're working on our homework, or we can make an appointment before or after school sometime. I can get you caught up on it. All right. I came up with x equals 1. You guys getting 1 for x? That's half of our answer, but we're almost done. We just need to find our y value. We need to go back to one of our original equations. Do you guys want to go with the first one or the second one this time? Any preference? Second one this time? All right, go on second. Y equals negative blank parenthesis minus 2. I left my x out because we have a number that we can put in for x now. It is 1. And then we just need to combine those. Negative 1 and negative 2 come together to create negative 3. And that's it. You just solved your second system using equal values. Let's do another one before we come back and graph. Example 2 here. Let's work through this one together really quickly, then we'll come back and graph together. All right. Can you go ahead and do that first step, the equal value step? This is the key part. Put those two equations together for me. Put an equal sign in between them. Basically, you're getting rid of the y's and you're just putting these two pieces together. Did you guys already do that? We got x's on both sides again. We're gonna have to deal with that. Do y'all want to get rid of the negative 3x or the positive 3x? The negative, let's get rid of the negatives. Negatives cause me to make mistakes. So if I can get rid of negatives, I usually choose to do that. So I'm gonna go plus 3x to cancel that. Same thing over on this side. All right, and then we're gonna work on solving this. We got a minus 4 here, so I think I'll go plus 4 to get rid of that. Both sides. And then we'll divide to get rid of that 6 there. All right, that's half of our answer. We can't stop there though. We need a y value also to finish this up. What do you want to do? First equation or second equation? You want to go second equation? Doesn't have a negative multiplying by the x. I think that's probably a good call. It really doesn't matter. You should get the same answer whether you put it into the first or second equation, by the way. So this is really just preference. Y equals 3x, but I'm leaving the x out. Minus 4. In place of that x, we'll put this 1. And then we'll work that out. What is 3 times 1 minus 4? 3 times 1 is 3. And 3 minus 4 is negative 1. All right, any questions? I do want to graph these really quickly and make sure we're getting the same answer when we graph them. So why don't you guys do this with me really quickly? This first one is negative 7x plus 4. So start at 4 on your y-axis here. And it's negative 7. We're going to think of negative 7 over 1. So from that point, count down 7 and over 1, but make it so it's a negative slope. 1, 2, 3, 4, 5, 6, 7 over 1. And then we can draw that line. 2 points is enough. That's all we're going to be able to get on there anyways. If I count down another 7, I'm going to go off the edge. The other equation has a slope of negative 1 over 1 and a y-intercept at negative 2. So draw me your first dot at negative 2 on the y-axis. And it's a negative slope, so count down 1 over 1. Down 1 over 1. Guys, stick with me here, please. Down 1 over 1, down 1 over 1, down 1 over 1. And that should be enough for me to draw my line again. And if we're looking for where the two lines cross, do they have the same x and y values that we came up with when we solved it algebraically? Totally. All right, you guys want to trust me that these ones are going to work out the same way? Well, you've already graphed them. And they did cross at 1 comma negative 1. All right. Let's go ahead and move on. Here's what I want you guys to do right now for I'm going to give you about, how much time we got left here? I'm going to give you about 10 to 12 minutes here. I want you to do as many of these problems up here where it says practice as you can, but you're going to need to do these in your notebook, okay? So follow those same examples that we had, that we just did. Have those examples out in front of you. My goal is for you to at least get through 2 of these, but some of you might be able to get through 3 or maybe even 4, okay? But try and get as many done as you can. Use the examples that we were just doing. I'll get you some answers here so you can check in just a moment. So let's talk about, can I get everybody to focus on number 2 for right now? Even if you didn't finish number 1 yet, go ahead and focus on number 2, please. So I did that first step where I combined my 2 sides together. And then this is where a lot of you raised your hands and asked me questions. And I said, just go ahead and move on. I'll show you how to finish it. Okay, so here's the deal. We had a negative 2x on both sides, right? We know we can't have x's on both sides. So my question is, do I get rid of the negative 2x or the negative 2x? Well, it doesn't really matter because you're going to get rid of negative 2x by doing what? By doing plus 2x on both sides. But isn't that going to get rid of both of them? They both go away. And then you end up with an equation that says negative 2 equals negative 4. And this is where a lot of you threw your hand up in the air and they're like, wait a second here. How do I solve for x? There's no x left. All right, and the answer is we don't. We're done. All we have to do is write down our final answer for this. Does anybody know what the final answer is? What do you think? Untrue statement would be a great way to say it. What's another way that we could say that? Say it louder. No solution. What did you say? Impossible. No solution. So typically in the math speak that we use will be no solution. But the other 2 things that you guys said were both correct. It's not possible to solve this. This is an untrue statement. And I love that you said untrue statement because that's kind of how we know it's no solution, okay? So guys, listen up here for a second. When you get to a final answer that looks like this and you have a number that's equal to another number, but they're not the same, that's a false statement. That leads you to the no solution. Now we will see some other problems that are going to work out kind of like this, but maybe when we get to the step, it would say -2 equals -2. So if we had another problem, I'm just going to put some squiggles here, and we did a whole bunch of steps, and let's say we did a whole bunch of steps and we got -2 equals -2. That's true, right? So we don't write no solution for this one. Did anybody know what, do you remember what we did in first semester when we ran into a true statement like this? We said all real numbers. Good. Now for this one, we're not going to say all real numbers because that doesn't make sense. We're talking about two different numbers. So we're just going to switch it up a little bit. Good memory. We're going to write infinitely many solutions. Okay, that's only if you end up with a true statement, like 4 equals 4, or 72 equals 72, or 0 equals 0. But that's not what we got in number 2. We got a false statement. All right, how are we doing on time? I want to do one more before I give you some time to work on homework. Let's do the word problem with Gia and Brewsty here. I told you guys the origin story of Gia and Brewsty last time, right? All right, so Gia and Brewsty are in this, they live together, and I think they did. They lived at the spaghetti warehouse, if I remember correctly. My niece's imaginary friends. And Gia is on a bike, and she is riding away from home at 15 miles per hour. Brewsty is at work 135 miles away. Wow, he lives far. And he's driving his truck 30 miles per hour toward home along the same road. All right, so we're going to use what we just learned to kind of create some equations here. Let's let y equal the distance from home. And we'll let x equal the time in hours. So we're going to write equations for Gia and Brewsty. To write an equation, this is like what we did on Tuesday. To write an equation, we need a start and we need a change. I'm going to write these off to the side here, and then we'll put them together into an equation over here. A start and a change. When we talk about start, we're talking about their distance from home. So read back through that paragraph and tell me, where does Gia start? How many miles away from home does Gia start? How many miles away is Gia when she starts? She starts at home, so she would be 0 miles away from home at that point, right? So she's starting at 0. What about Brewsty? How far away is Brewsty when this whole thing starts? Brewsty is 135. All right, I want you to think about their speeds. What is Gia's speed or her change? Hers is 15. And is her distance getting bigger or is it getting smaller? She starts at 0 and she's getting further away from home. So her distance is getting bigger, right? So her speed would be a positive 15. What about Brewsty? His speed is 30. Is his distance from home getting bigger or smaller? Because he's heading towards home, right? So his distance is getting smaller and smaller and smaller. So what do we need to do to this 30? We'll make it negative. So once we have a start value and a change, it's really easy to write the equation. It's y equals mx plus b. M is going to be your change. B is going to be your start value. So Gia's equation would be y equals 15x plus 0. Could you go ahead and write Brewsty's equation for me, please? Which number is going to go in front of the x for Brewsty? The negative 30. The change always goes in front of the x. The start value goes at the end. And there we go. We've got two equations. Now, no, yeah. I do that from time to time. I'll switch numbers around. I have some undiagnosed dyslexia. Thank you for pointing that out. It should be 135, right? Okay, thanks for the correction. Okay, now remember, we learned how to graph or how to solve these by graphing. Would you want to graph these two equations on a graph paper? No way. You want to try and find a y-intercept of 135 and then count down 30 and over 1 a bunch of times? No, so this is why we want to learn these algebraic methods. So let's do what we just did a second ago. Can we agree we don't really need this plus 0 here? I'm going to go ahead and get rid of that plus 0. Just call it 15x. Okay, so let's combine these two equations together. 15x equals negative 30x plus 135. So that's our first step, is we just combine the two equations together with an equals in between. And then we need to solve them. So I see x's on both sides. Which x do you want to get rid of, the 15x or the negative 30x? The negative 30, let's do plus 30x. Yes. I will send her when she gets back from restroom. I don't know why I wrote 30. That should be plus 30, not 15. Sorry, I got distracted. $15 and 30 is 45. Those cancel, we get 135. One more quick step, we'll divide by 45 on both sides. And 135 divided by 45, I want to say is 3. Someone got a calculator? Is it confirmed? It's 3? Thank you. X equals 3. Probably ought to find y also, right? So to find y, we're going to take that 3 and plug it either into our first equation or second equation. Which one are you going to choose this time? I think the first one is an obvious choice this time. It's way simpler, right? Let's do that. So here's my first equation coming down. It says y equals 15x, but I know what x is. X is 3. Anybody know what 15 times 3 is? 45. All right, so we got our solution, but we want to be able to interpret it. How long did it take for Brewsty to pass Gia? X is 3 and X was the time. So it would make sense that we would use the X value for that. So that would be 3 hours. Is that right? Okay. And then how far from home were they when they passed each other? Y was 45, that was miles. Yeah, so 45 miles. All right. So we're going to skip problem 7 and 8 for right now. I do want to point something out because I'm going to ask you to do this when you come in on Monday next week. Some people had trouble with this language before. Do you know what it means when it says G is broke as a joke? How much money does she have? 0, right? So, all right, let's pause there. Folks, the big thing today is the equal values method. And the key step for equal values method is where you take these two equations and you stick them together. When you do this, you create an equation that you can solve for x. Once you know x, then you plug it back into one of those equations and solve for y. So that's the key thing. Right now, before you go, can I get your, before we start on our homework rather, can I get your thumb meter on how you're feeling about this? Like I could ace a test on this right now, it would be thumbs up. Thumbs down would be like, I've never heard of equal values before. Somewhere in the middle is probably where most of us are going to be right now. I kind of get the big idea, but I'm going to need some practice before I'm feeling really confident. Okay. All right. Thank you, folks. I'm going to go ahead and pass out your homework. We've got 15 minutes left. I would love for you to spend that 15 minutes working on your assignment, getting a good